Hello, you are welcome to another episode on Tomex Academy. Today we are going to be talking about chemical equilibrium. Under this, we are going to talk about reversible reactions, Le Chatelier principles, and equilibrium constant. Learning outcomes. At the end of this lesson, learners will be able to 1. Identify the factors that affect the position of equilibrium of a chemical reaction. 2. Predict the effect of each factor on the position of equilibrium. 3. Determine the effect of these factors on equilibrium constant. This is starter video on chemical equilibrium. You can watch this for further explanation. Chemical equilibrium is a condition in the course of a reversible chemical reaction in which no net change in the amounts of reactants and products occur. Then, factors affecting the position of equilibrium. They include temperature, pressure, and concentration. Chemical equilibrium is dynamic. When the forward and reverse reaction take place endlessly and simultaneously with equal rate. Therefore, chemical equilibrium is called dynamic equilibrium. Also, we can say chemical equilibrium is when the rate of forward reaction and backward reaction are equal. A reversible chemical reaction is one in which the products, as soon as they are formed, react to produce the original reactant at equilibrium. The two opposing reaction goes at equal rate or velocity. Hence, there is no net change in the amount of substances involved. Now, let's talk about Le Chatelier's principles. Le Chatelier's principles state that if a change is applied to a system at equilibrium, the position of the equilibrium will shift in a direction which counteracts the change. Effect of change in temperature. In a chemical equilibrium, when you change temperature, when there is change in temperature, what will happen? Adjustment in the equilibrium is determined whether the reaction is endothermic or exothermic. First of all, adjustment in the equilibrium is determined whether the reaction is endothermic or exothermic when there is change in temperature. So it can be in two ways, that is endothermic. When we say endothermic, the word endothermic simply means when heat is absorbed from the surrounding. And when we say exothermic, it simply means when heat is given out to the surrounding. Now, effect of change in temperature. If the reaction is exothermic, that is when heat is given out, released to the environment. The reaction is exothermic. If the reaction is exothermic, an increase in temperature shifts the equilibrium towards what? Towards the reactant, while a decrease in temperature shifts the reaction towards the product. If the reaction is endothermic, an increase in temperature shifts the equilibrium towards the product. A decrease in temperature shifts the reaction towards the reactant. Changes in temperature result in changes in the value of the equilibrium constant. Please, students, you should take note of this. Changes in temperature result in changes in the value of the equilibrium constant. And you need to know this principle. You need to understand this, and you need to memorize it. You need to know if the reaction is exothermic, what will happen? If the reaction is endothermic, what will happen? You should know this. Once you know this, you'll be able to attempt any question that is related to this. Effect of change in pressure. If the number of moles of gaseous products equals the numbers of moles of gaseous reactant, then pressure changes have no effect on the equilibrium reaction. This is clear. If the number of moles of gaseous product is greater than the number of moles of gaseous reactant, then an increase in pressure shifts the equilibrium towards the reactant. A decrease in pressure shifts the equilibrium towards the products. You understand this better when we get to the example. If the number of moles of gaseous reactant is greater than the number of moles of gaseous product, then an increase in pressure shifts the equilibrium towards the products. A decrease in pressure shifts the equilibrium towards the reactant. Note, changing volume pressure only affects gaseous equilibrium. Adding an inert gas does not change the equilibrium position. Please take note. Effect of changing concentration. Look at this equation of reaction. A plus B in gaseous state. So these are the reactant, while C plus D are the product in gaseous state. Now, adding reactant causes a shift to the right. That is, when you add reactant, what will happen? It will cause a shift to the what? To the right, as forward rate increases and reactant form products. Removing reactant, that is when you remove either of A or B, which is reactant, causes a shift to the left, which means it will cause a shift to the left as the forward reaction rate slow. That is, the forward reaction rate will slow, then it will cause a shift to the left, causing a shift towards reactant. Adding product causes a shift towards reactant, that is product, when you add either C or D, causes a shift towards reactant as the reverse reaction rate increases. Removing product causes a shift to the right, that is when you remove the product, when you remove either of C or D, what will happen? It will causes a shift to the right and more product formation. That is, once you remove the product, there will be more product formation, and that shift to the right. So this is the summary of what happens when you changing concentration. This is A plus B is the reactant, A plus B reactant, C plus D product. So increase or decrease in concentration. When you increase or decrease concentration, equilibrium position will shift to right or left. So try to understand this. If you understand this, you'll be able to solve questions that are related to this. Now, let's look at some examples. Predicting shift in equilibrium position. So looking at the equation of reaction, we are given this equation of reaction: nitrogen oxide plus oxygen to give NO2. So what happened to the equilibrium? A, if oxygen is added to the system. If oxygen is added, that is, take note, oxygen is reactant. So if oxygen is added to the system, the question is saying that that's if reactant is added to the system. B, NO is removed, that is, if reactant is removed. So what these two questions are saying is if reactant is added and if reactant is removed. So solution: the equilibrium shift if oxygen is added, the equilibrium shift to the right. The equilibrium shift to the right using up some of the added O2. That's what will happen. And B, and if you look at our rules, other concentration, you see that if you look at the rules, you'll be able to you should understand the answers, the solution. Now, if NO is removed, that's reactant is removed, because NO is reactant, then what will happen? The equilibrium shift to the left. Shift to the left, forming more of what? Forming more of NO. Now, let's look at example 2. The following reaction is at equilibrium. Nitrogen plus oxygen give this nitrogen oxide gas. If we increase the pressure, in what direction would the reaction move to re-establish equilibrium? If you look at this, the number of mole on the reactant and products are equal. Total number of mole is total number of mole on the reactant is 2, while total number of mole on the product is 2. Oxygen, this is 1 mole. Nitrogen, this is another 1 mole. So 1 plus 1, that gives us 2. But here we have nitrogen oxide gas, and here this is 2 mole. You can see the coefficient is 2. If nothing is here, it means it's 1. So any number greater than 1 will be written. 2, 3, 4, 5. Now, if we increase the pressure, in what direction will the reaction move to re-establish equilibrium? Solution. The number of gas molecules on both sides of the equation are equal. Yeah. So, changing the pressure will not change the equilibrium position. Changing the pressure will not change the equilibrium position because the number of gas molecules on both sides of the equation are equal. Question number 3. If temperature is heated, predict the position of this equilibrium. If temperature is heated, predict the position of this equilibrium. Now, if you look at this equation of reaction, N2O4 in gaseous state give 2NO2 in gaseous state. Each change, the H means each change. Each change is plus 57 kilojoule. Plus 57. What does this mean? This simply is telling us that the reaction is endothermic reaction. So, and we will now go to our rules. When reaction is endothermic, what will happen? So because it is an endothermic reaction, you can see, then heating the system shifts the equilibrium to the right. That is, when the reaction is endothermic, the equation will behave, heating the system will shift the equilibrium to the right, and when the reaction is exothermic, the equation of reaction will also behave in another manner. So because it's an endothermic reaction, heating the system shifts the equilibrium right, consuming energy, cooling the system, shift the equilibrium towards the reactant. So that is, if you heat the system, it will shift the equilibriums to the right. So that's what the solution is saying. Now let's talk about equilibrium constant, Kc. The product of the equilibrium concentration of the product divided by the product of the equilibrium concentration of the reactant, with each concentration term raised to a power equal to the coefficient of the substance in the balance equation. Now, to generalize this expression, consider the reaction. That's reactant A plus B. This small letter A is the coefficient, while small letter B is also the coefficient. That is talking about the numbers of molecules of A, B, number of molecules of C, small letter D, number of molecules of D. Now, the equilibrium expression for this reaction will now be, so if we are going to write the equilibrium expression for this the above reaction, it will now be equilibrium constant Kc will now be equals to, always remember that it will always be product over reactant. Product, that is concentration of C raised to the power of coefficient of that C multiplied by a concentration of D raised to the power of coefficient of that D, all over then the reactant. Concentration of A raised to the power of A, concentration of B raised to power of B. Students make mistake a lot in this area. Sometimes some students will do reactant over product. It's wrong. It's always product over reactant. That's concentration of product over reactant, and it must raise to the power of what? The coefficient of what? The coefficient of each. Like C now, the coefficient of product C is C. You can see coefficient of product D is small letter d. Now example, let's go through the example so you understand better. Write the equilibrium expression for Kc for the following reaction. Now look at A. I said it's always product over reactant. So what is our product? Product is oxygen, concentration of oxygen. What is the coefficient of oxygen? 3. You can see raised to power of 3. Then all over, what is our reactant? Reactant is O3. This O3, then raised to power of coefficient. What is the coefficient of this O3? 2. So it's straightforward, it's simple. B, our Kc, product is NOCl. So concentration of NOCl raised to power of the coefficient is 2 all over reactant. What is our reactant? Nitrogen oxide, concentration of NO. Then because NO is having coefficient of 2 raised to power of 2. Now multiply by concentration of, there is no need for you to put multiplication sign. Concentration of this then is multiplying this already, concentration of this. So there's no need to put multiplication sign. You can see I did not put multiplication sign. So Cl2, coefficient of Cl2 here is 1. That is why you did not see anything. So concentration of Cl2 raised to power of 1. Now the last question. Product here is this. So you write the product exactly the way you see it here. The ion. So the ion, you put it here. That's the concentration of this all over what? All over concentration of reactant. So reactant are silver ion, concentration of silver ion, then multiply by concentration of ammonia. There's no need to put multiplication sign. Just write it the way I've written it. So concentration of ammonia. Then what is the coefficient of ammonia? 2. You can see the coefficient here is 2. If you omit this 2, it's not correct. Take note. And always take note when you are writing equilibrium expression for Kc. If you have any element or any compound in solid state, it will not be, you cannot use any element or compound in solid state to write equilibrium expression, which means you are going to omit any element in solid state. I'm going to show you an example. When we get there, we're going to show you. Now, effects of temperature, pressure, concentration on Kc. Kc value depends on temperature, pressure, and equilibrium concentration, and does not depend on catalyst and initial concentrations. Because pressure is proportional to concentration for gases in a closed system. The equilibrium expression can also be written in terms of partial pressures. That is, equilibrium expression can be written in this form. Now, Kp equals to this, then where the N is the difference in the number of molecules of product and reactant in the equilibrium. Now, test your understanding. Now, write the following equilibrium constant expression. This is what I'm saying. If you look at this number, hey, you can see this element Cr is in solid state. Also, the product here, Cl, is also in solid state. So you will not use these two elements in solid state. If you want to write the equilibrium expression for this, you are going to take this aqueous solution only. So those one in solid state would not be used. So to write equilibrium constant Kc for this, it will now be concentration of this Cr chromium 3 plus all over concentration of what? This silver ion raised to power of 3. So this solid the 2 in solid state will not be used. Then you should be able to try this. Which of the following changes will increase the total amount of Cl2 that can be formed? If you follow the rules and regulation that was given in the concentration slide, when we are talking about effect of concentration, you should be able to attempt this. But if you don't know how to solve it, the solution is right below here. Now, just like I said, you can see you will not use the element in solid state, so only those in aqueous, and always start from the product, concentration of the product over concentration of the reactant. And this silver ion is raised to the power of 3. If you check it, the coefficient of silver ion is 3. Why this chromium has no, the coefficient is 1. That's why you can see, that's why there's no need for you to write 1, except if it is 2, 3, you can write it. So Kp, this is how to write the Kp. So this is straightforward. This 4 simply means the coefficient. So if you look at it, you can see now this 4 means coefficient. So product is still product over reactant. So the same thing with pressure too. Pressure has no effect on solid, so you will not use the solid. You are going to use only those in gaseous form, so which is hydrogen all over water. So question number 2, this is the solution. In this lesson, you have learnt that chemical equilibrium is a condition in the course of a reversible chemical reaction in which no net change in the amount of reactant and products occur. Factors affecting the position of equilibrium include temperature, pressure, concentration. Le Chatelier principle: if a change is applied to a system, at equilibrium, the position of the equilibrium will shift in a direction which counteracts the change. So this is assignment. Do remember to do your assignment. So doing assignment facilitates learning process. So make sure you do your assignment. We have come to the end of today's topic on Tomex Academy. Please kindly subscribe to our YouTube channel so that you can have access to our future videos. Thank you.